practice all semester.
Yeah, I don't like, I thought it was just me, but maybe it's me and Sean, but I don't have the calendar. Like, I remember you talking about
Up at the extras over there. You might have just forgot to grab it when you came in, but they're up there if you need them.
Not really.
And then remember the calendar goes in your plastic sleeve.
Are we?
Do you have your little index card? These guys here. Cosecant, secant, cotan. Remember these guys? Something's going on back there. I don't know what. Cole, what's going on? Secant, cosecant, cotan, these are called reciprocal identities. I just didn't call them that last semester. They're called reciprocal identities. Why? Because they're reciprocals. Tan and cotan, these are called quotient identities because on the right-hand side you have a division, and the answer from division is called a quotient. These guys, the three that I did in red, the three that are up there in blue, are called the Pythagorean identities or Pythagorean identities because all of these come from a squared plus b squared equals c squared. Pythagorean identities, quotient identities, reciprocal identities. Take a look at the first three things on the list. So reciprocal and quotient identities is the first thing we're going to do, and then Pythagorean identities, we're going to do that all today. Then these two little things we haven't done that you've never seen before, sum and difference will come later on in the unit, and then double angle. What's an identity? Here's the formal mathematical, like Webster's dictionary definition. It's an equation that is satisfied for all values of the variable for which both sides of the equation are defined.
That makes sense.
It always makes sense when you read in the dictionary, right? Here's what it really means, the informal. They're equations that we're not going to solve because we did that in Unit 1. They're equations where we're going to prove that one side is exactly the same as the other side. They're equations where we prove that the two sides are equal. Or not equal. They're equations where we prove that the two sides are equal. They are not equations you're trying to solve. We've been there, done that. That was 6 classes in Unit 1. So take a look at example 1. It looks very much like stuff we've already done. The key difference is the word prove, not solve. So you have to be really careful on the exam that you're reading not that you don't read on the exam, but sometimes when you're a little stressed and panicky, you tend to gloss over words and go right to the equation, and your brain is going to want to solve. Because we've been telling you to solve equations for 4 years. Solve, solve, solve. This says prove, it doesn't say solve. You could go ahead and you could find the values of theta and you could solve it. That's going to get you 0 on this question because it says prove. There's very distinct things you cannot do and there's very distinct things you can do. You cannot use a graph. A graph is not a proof. So you cannot show me the picture of both sides and say, look, the graph is exactly the same. That's not a proof. You cannot substitute in a value for theta. So you can't randomly pick a unit circle value pi and put it in and show me that the equation works. The reason you can't do that is because that only proves it equals for that one value. We want to prove that it's equal for all values. So you can't just randomly pick one and throw it in. You cannot multiply or divide both sides by the same value, which I'll talk about why in a second. You cannot cross multiply. And you cannot write an equal sign between the two sides, which I'll explain when we go through the first question. Those are the nots. Cannot do those things. Take a look at the 3 things you can do. That's it. 3 little things. These are your choices. You can substitute equivalent expressions on the same side. So for example, if you have cosecant, you can put in 1 over sine. If you could have tan, you can put sine over cos. If you've got a sine squared, you could put 1 minus cos squared. That's called substituting equivalent expressions. So you can use anything on the front or back of this card. The second thing is you can work on one side and then you can work on the other, which we'll explain when we do an example. And the third thing is a must. We will all be doing a dance of joy when we're finished the question. Okay, so start thinking about how you're going to chair dance, how that dance of joy is going to go, because we will all be doing it because they are that exciting. Oh, you can do whatever you want. There will be dances of joy. I can always tell in the final exam when you get the identity, because people are like, yes! Like there's always like a little yay when you get the identity. That's the only things you can do. That's it. Put your pens down. You're going to watch me do the first example. You're just going to watch. Then I will do it over with you. I don't want you to have to try to copy and understand. So we are going to prove that when you take sine of an angle, any angle in the world, and you multiply it by secant, and then you multiply that by cotan, it equals 1. What? How does all of that equal 1? So the first thing I tend to do is put a Mr. Squiggs in between, because you can't put an equal sign. If you put an equal sign in your work, you're saying they're equal, but that's what you're trying to prove. So you can't state they're equal until you know that they're equal. Okay? Here's the good things about identities is there's a million different ways to do them. Just because I do it one way and I prove it, and you do it a different way and prove it, it doesn't mean you're wrong and I'm right. There is always many ways to do these. That's the good thing. Check. The other good thing is there's no right answer in the sense that you know you're done when the two sides are equal. So if you've already looked ahead on the answer sheet or in the book, there's no answer key for this because you know when your two sides are equal. Check. The bad thing is there is not a set of instructions that I can give you. I cannot say always do this step 1 and always do this step 2. It doesn't work that way. I can give you general guidelines, which is what I did in the next box. These are general hints what you want to do. It doesn't mean they're always going to work. It doesn't mean you're going to do them in this order. They're just hints to do the question. The more identities you do, the easier you become. I can look at one now and I can know exactly how it's going to work. You're not going to be able to do that at first. At first, like any kind of puzzle, you're going to get stuck and you're going to do it the wrong way and it's not going to work and you're going to need a hint, and that's okay. The more you do, the easier they become. So here's just some hints. Typically what we do first is we change everything to sine and cos. Rather than dealing with 6 different trig functions, we like to get it down to 2. And we know from these formulas everything is related to sine and cos. We look for anytime we see sine squared plus cos squared. I'm going to highlight that. That is going to jump out at you like with little flashing lights. We love when we see sine squared plus cos squared theta, because what do we know it's equal to? 1. So we can at any point take that out and put in the number 1, because that's our Pythagorean identity. We simplify all fractions, and this is going to involve a lot of fraction work. Who are my typical right brains? And I'll add, who are my right brains that like to put fractions on one line of their lined paper? Yeah. Don't do that. Don't squish them. You need to be paper wasters with identities, because if you're trying to add and divide and it's all squishy in one line, you just can't see what's on the top, the bottom, and I can't follow it. So you really need to take 2 lines to do your fractions. Trust me, Andy, trust me. 2 lines to do your fractions. 2 lines. You want to try to factor when you can. How do you know if something's factorable? It's quadratic. So the minute you see a squared in there, you probably want to factor it. Typically, we start working on the side that's more complicated because there's more stuff we can do with it. If you're stuck, we go to the other side and we see what we can do to that side. And the very last step, if you've done everything else and there's nothing else you can do, we multiply by what's called the conjugate binomial. That should sound familiar because you saw it in grade 11, and I'll talk about it when we get there. These are general guidelines. This is not a method. That's why it doesn't say 1, 2, 3, 4. It's just in general, these are things that we try. Again, you're not copying, you're just watching me. First thing you do is you pick a side. Pick the side that's more complicated because there's more stuff to play with. If I pick the right-hand side, I have 1. What do I do with that? Nothing. So I'm going to pick the left-hand side because there's lots of stuff going on. What you want to do typically is change to sine and cos. So I'm going to keep the sine theta, but I want secant out. So I go to my card and I say, what is secant equal to? So I'm going to take it out and I'm going to put 1 over cos. That's substituting an equivalent expression. We're allowed to do that. Anything on the card is fair game as long as it's equal. Cotan, I don't want that in there. I want something that's related to sine and cos. So I don't want to pick my 1 over tan. I want to pick cos over sine. And the reason I want to do that is because I want 2 functions as opposed to more. Okay, so far I have done everything okay. I have substituted expressions that are on the card. This is all multiplication. So I'm going to multiply top times top times top, bottom times bottom times bottom. Little imaginary one under the sign. Sine times 1 times cos. Sine cos. I'm just going to smush them together. On the bottom I have 1 times cos times sine. Cosine, and I'm just going to write it the other way, sine cos. What is anything divided by itself? I have just proven my first identity. That's how you prove an identity. It's not a solution. I didn't solve for theta. I don't care what theta is. It's not what the question asks. It's prove this is true for any value of theta. There is a concluding statement, so I now have to say I know it's been proven, and you have two choices. You can do LHS, triple equal sign, RHS. Left-hand side has been proven to be equivalent to the right-hand side. The other one you can do is QED. Please don't say quid. It's Latin. It stands for quota errata demonstrata. Quota errata demonstrata. It means it has been proven. That's it. That's the work. That's how you solve an identity. You pick one of these, not both. You just put one. QED. No, you just leave it. Now you copy.
I don't like nonsense.
I get it, Lefty. I get it.
You're like circle in, like this is the answer.
Sine theta times secant theta times cotan theta equals, ooh, I put my squiggly line too early. I got super excited. Equals 1. I'll give you that, and you can have your card, whichever one you like better. Again, I put the Mr. Squigs in there, and the only reason I do that is just to stop myself from writing an equal sign, because you're so used to writing it, you're going to want to write it with these, and you can't do that. It's a half mark off, because you're saying it's equal, but you haven't proven it's equal. Okay, I'm just following my little hints here. First hint is change everything to sine and cos. So we take a look, anything that's not sine or cos has to go. So secant has to go and cotan has to go. What we're using on the card, you just didn't know them, were reciprocal identities, quotient identities, Pythagorean identities. That's what these are called. Sine can stay. What am I going to put in the place of secant? 1 over cos, that's a reciprocal identity. What am I going to put in the place of cotan? That is called a quotient identity. What are you looking for? Oh, there's a bucket in the cabinet. It's like a clear bucket.
Why do you have to name them?
I know, because you'll see those words. They'll say, use reciprocal identities to prove this, and you'll be like, what? So I'm just telling you, that's what they're called. Okay, going back to my hint, change to sine and cos, check. Do you see anything with sine squared plus cos squared? Do you see that anywhere in the expression? So we skip that. Simplify all fractions. So that's what I'm going to do next. Top times top times top, bottom times bottom times bottom. Sine times 1 times cos, sine cos. On the bottom, 1 times cos times sine. Sine cos, cosine, doesn't matter, whatever way you write it. Anything divided by itself? We are done. Or left-hand side is equivalent to right-hand side. No, don't call it quit. Doesn't matter. Again, you need to be really careful to read the instructions because these look like equations that we've solved, and your brain is going to naturally want to solve. So if you don't catch the word prove on the exam, you're going to grab this, you're going to do a whole bunch of work, you're going to solve for theta, you're going to be like, theta is pi on 6, and 5 pi on 6, I'm so smart, unit circle, woo! And then you got 0 on the question because it asked you to prove. The units like separate. No. Yeah, it's all random. They don't go, hey, identity with flashing arrow. No, you got to figure that out on your own. No, it's all mixed up. Well, because just because I teach it in order doesn't mean that Fort Richmond teaches it in the same order that Kelvin does, that Churchill does, right? Provincial, so no. Questions so far? Sometimes you're going to get stuck and you're going to come up to ask for help, and that's great. The first thing I'm going to say is have you done all of these things? If your answer is no, I'm going to send you back to do all of these things. So this is kind of like our checklist when we first go through. Example number 2. Cos theta plus tan sine theta equals secant theta. Like really, how can all of that stuff on the left be equal to secant? How does that work? That all that crap is just equal to secant. Again, the only purpose of that line is so you don't write an equal sign. If you don't like the line, don't write the line, just don't put an equal sign. Here's a couple more things to watch. Make sure you're not dropping your thetas. That's really, really common. Make sure you're not switching your variables. So if it's in x, you stay in x. If it's in theta, you stay in theta. If it's secant x, please don't write sex like a lot of you did on your quiz. And don't put that equal sign in between. Pick a side, left-hand side or right-hand side. Why do you want to pick left? Because there's more stuff to play with. Sine and cos, we typically want to stay. We want everything else to go. So it's tan that I want to get out of here. Again, this is not the only way to solve identities. It's just a way to start. So I'm going to keep cos. I'm going to take tan out, and what am I putting in its place? And then I still have that sine theta hanging around behind the tan there. Do you see any sine squared plus cos squareds? No. So now we're going to simplify all fractions. I have an addition and I have a multiplication. What do I do first? Why do I do multiplication first? Bed mess. So for visual people, sometimes it's handy if you just cover that other side, because sometimes when you see too much, you want to start doing crazy things. All I'm going to do is this multiplication. Imaginary one on the bottom, top times top, bottom times bottom. Sine times sine. Perfect. And on the bottom, cos times 1. And now I'm going to add that little cos that I had at the beginning. Get no equal sign. No equals anywhere in here. None. Evil equal sign. Now I'm going to do the adding of the fraction. For people that are weak in fractions, just off to the side. 1/3 plus 2/7. How do we do that? Common denominator, 3 and 7. What's the common denominator? Okay, then how do we get from 3 to 21? So in our head, we're like, well, we know we need to multiply by 7, so I got to multiply the top by 7. 1 times 7 is 7. And then I go, okay, here, what did I multiply by? Okay, and so 2 times 3 is? Okay, what do we do once we have the common denominator in the numerators? Add what? Just the numerator. So we keep that 21, we add the tops, which gives us 13. Okay? We're going to do the same thing here, it's just going to have coses and sines. What's the common denominator between 1 and cos? We'll multiply them together just like we multiplied 3 times 7 to get 21. What's 1 times cos? Cos. So I'm going to put the first fraction over cos, and I'm going to put the second fraction over cos. Yoshi, wake up. That lasagna made you tired. How did I go from a 1 to a cos? What did I multiply by? Now, I wouldn't normally write this, but just because it's our first one, I'm just going to show what we're doing in our head is we multiplied by cos. And so cos times cos is cos squared on the top. The second fraction, what did I multiply to go from cos to cos? Times 1, so sine squared times 1, sine squared. Now I keep the bottom and I just smush the top together. Smush, it's a very technical math term. It means plunk it together. So cos squared plus sine squared is cos squared plus sine squared. Oh, what now? What do you know about cos squared plus sine squared? So I can take it out, I can put in 1 over cos. It's what? 1 over cos is? How do you know when we're done? Because the two sides are exactly the same. What if they aren't? There are certain identities that will not work out. I have never seen them give you one on the exam. So we're not trying to trick you. They will work out 99% of the time. You would not put a QED. You would just leave it unsolved. Unproven, I should say. No equal signs. No. No equal signs. Now, what you're going to say in about 2 days when you're working on this homework by yourself, you're going to be like, but it looks so easy when you do it. Yes, because I have solved a bajillion of these. And I have practiced so much, I can see right from the beginning, I knew we were going to get a cosquared plus sine squared, it was going to be equal to 1. You just need to practice. The more you practice, you're going to see patterns in the questions, the easier they're going to become. Number 3. A tan plus a cotan somehow magically is equal to a secant times a cosecant. Again, you don't have to put the squigs. I just do it because I naturally want to put an equal sign and I need to stop myself. First step, pick a side. Left-hand side, right-hand side. Well, they both have 2 functions. Pick one. Right. Probably want to take secant out. Again, flip to your card. Once you did a few of these, you won't even need the card. You'll know secant is equal to. And cosecant is? This is a multiplication, so top times top, bottom times bottom, 1 times 1. Cos times sine. Cosine, we just slap them together when they're different. Okay, change sine and cos. Look for sine squared plus cos squared. Simplify our fractions, we did. Can we factor this? You'll know because there'll be a squared. It has to be quadratic to be factored. Start working on the sides more complicated. Okay, we picked a side. I'm stuck. Okay, so let's go to the other side. So that's what you do when you're stuck. You just flip to the other side and let's try to make it equal this side. Okay, tan comes out. What's going to go in its place? Sine over cos. Cotan becomes? You can already hear some light bulbs going off. Okay, we're adding fractions. What's the common denominator between cos and sine? Sine, cos, cosine, however you want to order it. Just remember the order doesn't matter because 3 times 4 is the same as 4 times 3, so it doesn't matter which one you put first. Now in our heads we go, how did I go from a cos to a cosine? What did I multiply cos by to get cosine? Sine, so the top, sine times sine. Here are a few more light bulbs going off. How did I go from a sine to a cosine? What did I multiply by to get the cos there? By cos, so the top, cos times cos. Keep the bottom, add the top. So the top is sine squared plus cos squared. Oh, what now? Dance of joy, dance of joy. Kate, your turn. Dance of joy. There's a lot of you not dancing. I will make you come up to the front and do it if you're not going to do it in your desk. I will seriously make you do it right up here for everyone. Dance of joy, go ahead. Nice. She's got like a slight head bob there. How are we liking identities so far? I like them, I'm getting them. Good. Remember, we're starting with the easy ones. Because cos doesn't exist by itself. It would be like me putting a square root with no number under it. Right? What does that mean if I just gave you a square root? Sine, cos, tan are just functions. They don't exist without a number. Number 4, look at this goodness. I can in the question, but then that's it. So sine plus cos over sine somehow equals 1 over cotan. Pick a side. Because you said right, I'm going to go to the left. Change the sign and cos. Already done. Try to factor. Is there any squareds? Combine the fractions. It's already done. There is only one fraction. I'm stuck. Okay, let's go to the right side. So that's why I went to the left, because there's nothing you can do. Now, real mathematicians, we pride ourselves on only ever working on the left. If we have to go to the right, we consider it failure. So we always work on the left. What do you want to do on the right? I don't want to go to 10 because I want to change everything to sine and cos because there's sine and cos on here. So I could go to 10, but then I'm going to take tan to sine over cos. So we're going to go cotan to cos over sine. Okay, any sine squareds plus cos squareds? Are there fractions to simplify? Yeah, we got two things we're adding here. What's the common denominator between 1 and sine? Sine. So the first one's going to be something over sine, and the second one's going to be something over sine. What did I multiply the 1 by to get sine? Sine, so the top 1 times sine is sine. What did I multiply the second fraction by? 1, so the top's going to be cos. Pause there and look up when you're done. Here's a common mistake. I see this all the time. People go, oh, well, sine over sine is 1, so I'm going to cancel that. But that's what your brain is going to want to do, because we've told you for years, simplify fractions, simplify fractions, simplify fractions. What did I do there? I went right back up. And that's common when you get into harder identities. You'll end up going right back to where you were 2 steps ago. That tells you whatever you did was not the right path. So if you happen to cancel, then you're like, oh, well, that clearly wasn't it. So let's go back to our sine over sine plus cos over sine. Let's finish it off. Keep the bottom. Smush the numerators together. And dance of joy, dance of joy. Oh, I enjoy jazz hands. I enjoy. Don't call it crud. I might have to hurt you. Probably shouldn't have said that into the microphone.
We have proof.
We're going to stop at number 5 for today. Look at this baby. Cotan times sine divided by secant magically becomes cos squared. The more you do, the easier they become. Pick a side. Good choice. What do you want to do with the left? I don't know. What's the first step on your hint box? Change the sign and cos. So what probably do we want to take out? What do we probably want to take out? Cotan probably want to come out, and secant probably wants to come out. Now this is where fraction squishers, the people that squish all their fractions onto one line, are going to run into trouble, because we need to keep a clear idea of what's on the top and what's on the bottom. What is cotan equal to? And then I still had that sign there, so I'm not touching him yet. I'm going to put a really big dividing line just to be really clear as what was on the top before, what's going to be on the bottom now, etc. Sure, absolutely. On the bottom, secant's going to become? So again, just some hints. I like to keep really clear my fractions, so I put them on 2 lines, and I always use a big dividing line from the dividing line in the questions, just so I'm clear what was where and what's going on. Now, if your brain is like, WTF, what is going on here? Cover the bottom, just look at the top. What do you want to do on the top? Ooh, no common denominator, because we're multiplying. What do you know when you're multiplying and you have something on the top and something on the bottom? Goodbye. What's left on the top? Now we just have a division of fractions. How do we divide fractions? Take the reciprocal of the bottom fraction. So 1 over cos is going to flip and become? Yeah, you got to be a paper waster with these. Is everybody clear what I did there? Took the bottom and flipped it? Because we're dividing fractions. And so when you divide fractions, you flip the second one. Cos times cos. On the bottom, 1 times 1. QED. Dance of joy, dance of joy, dance of joy.